Hello, this is Dr. Strickland. In this video, we will continue our investigation of the conformations of acyclic compounds. Take a minute to read through these student learning objectives. These are the things you should be able to do by the end of this video so that you're ready for the more difficult things we will do together in class. So we're going to take a look at a little fancier molecule to do our acyclic conformations. We're going to move to butane. There are 4 carbons in butane. And once there are more than 2 carbons in the parent, you have to specify which carbon-carbon bond is represented by the circle in the Newman projection. So in this case, we're going to choose the C2C3 bond. So that's the covalent bond that connects carbons 2 and 3. All right, so in a Newman projection, as you know, this circle represents 2 bonded carbons. And so my front circle that has the 3 bonds that meet in the middle represents C2. And then C3 is behind that. And these 3 lines that don't meet in the middle are understood to represent the bonds to the 3 things that are in pink over here. So I found the carbon-carbon bond that we were interested in as the viewpoint. And then I made these guys yellow and those guys pink. So I'm going to make these 3, the methyl group and the 2 hydrogens that are attached to carbon 2 in yellow, just to correspond up here. All right, so that makes these 3 attached to carbon 3, which is behind carbon 2. All right, so in the anti-conformation, we have the staggered conformation in which the largest thing bonded to the front carbon is as far away as possible from the largest thing bonded to the back carbon. And there are different ways to say that. You can talk about dihedral angles. You can specify which carbon is the front carbon and the back carbon. I just did it this way as a general way to kind of begin. So in this case, the largest thing on the front carbon is a methyl group, and the largest thing on the back carbon is also a methyl group. So I'm going to put the methyl group down here, and it's anti to the methyl group that's on carbon 2. All right, and so I'm going to highlight these bonds in pink, and they will not meet in the middle to remind me that they're bonded to that back carbon, which in this case is carbon 3. Okay, so when you get to things that are larger than ethane, there are a couple of different staggered conformations and a couple of different eclipsed conformations. So let's do all of our Newman projections first, and then we'll come back and do perspective formulas. So what we're going to do is we're going to rotate the back 60 degrees and move the back ones like this. Now, they're actually overlapped by these 3 things attached to carbon 2. But if I drew them like that, you'd never be able to see them. So we're just going to offset them just a little bit. And so if I label these guys A, B, and C, just to kind of keep track of things for a bit, and then label these guys D, E, and F, then you'll be able to see better where things moved to. All right, so at this point, it might be a great idea for you to do the front carbon on all 4 of these Newman projections. You know, to kind of put in the thing that's the same on all of them before we do the things that are different. So I'm going to do that. All right, so come on back up here. So we rotated the back clockwise 60 degrees, and that puts this hydrogen up here, and it puts this hydrogen down here, and puts this methyl group over there. So if you're tracking letters, this is A, B, and C, and this is D, E, and F. Okay. All right, so let's do another turn to the right. And that gets us to the second staggered conformation, So we've got that same kind of arrangement of the 3 bonds in the front with the 3 bonds in the back. But now the methyl group has moved from here over to here. So the methyl group is here. The other 2 are hydrogens, the way we've done them. And so we stick with our A, B, and C. Then methyl group is F. This guy is E. And this guy is D. All right. And then one more, the most seriously eclipsed one, involves the eclipsing or overlapping of the 2 largest things. And so again, we're going to do just that little bit of offset. But now the methyl group has moved up to here. It's the most serious steric interaction. Okay, so one more time. A, B, and C, and the methyl group, which is F, has gone up there, E, and D. Okay. So 2 staggered conformations, 2 eclipsed conformations. The gauche conformation is not as stable as the anti because these methyl groups are not as far apart as possible. The eclipse conformation is the least stable one because the 2 largest things are closest together in space. This guy I called the less seriously eclipsed conformation because it's the only one that doesn't have a name, and I felt bad for it, so I gave it a name. But you can see that the substituents on carbons 2 and 3 are eclipsed, but this steric hindrance, steric interference is not as bad between a hydrogen and a methyl as it would be between 2 methyls. All right, so the other thing I want us to do in this video is to go from Newman projection to perspective formula. So if you take your left hand and pretend this is your Newman projection so that the back of my hand is carbon 2 and my palm is carbon 3, and my thumb here is B. Okay, then if I turn it to the left, then B will be coming out towards you. See that? Okay, so carbon 2 goes over here to the left. So these things are here, and the things attached to carbon 3 are here. And we know that the methyl group is up here and down here, and B is right here. So B goes in the front, C goes in the back. Now, right now that they're both hydrogens, but they won't always be. Okay, same kind of idea. The other thing that's on the right will also be coming out towards you. And they are right now 2 hydrogens, but they won't always be. And this way you can track the conversion of any Newman projection to any perspective formula, in either direction. Okay, so let's do the same sort of thing over here. We know that these are if we turn to the left like we did before, we know that the solid line here is A. Actually, A, B, and C don't even change, do they? It's just a question of where D, E, and F went. All right, so we turn again this way. The things that are on the right come out towards you. So this is a hydrogen, and this is a hydrogen, and did I get, excuse me, that's not true. This is a methyl group. Okay, so the things, this comes out towards you, F goes away from you, D is in the plane of the paper. Okay, so this is B, and F and E. All right, let's just make sure that's right. It's coming out towards you, that's going back. Okay, I think we're good. All right. One more check just to be sure. All right. Okay, I think we're good here. Now, when you come down here, I want you to do some. You know, in any perspective formula, you've got a line in the plane of the paper, which is also in the plane of this carbon-carbon bond in the middle. And we can do that for the Gaussian, we can do it for the eclipsed. And we know that the way we set this up, A, B, and C are over here in their very same places. Just a question of where the other guys went. All right, so let's draw in A, B, and C. Because it's nice to keep one part of what you're doing stable while you change the other part. It's like in an experiment where you only change one variable at a time. All right, so A, B, and C. Sorry, B and C. All right, so now I want you to turn both of these, okay, the same way that we did, and show me where the pink ones went on these perspective formulas. And then come on back. All right, welcome back. So you know the one that's on the right is going to come out towards you. The solid line is going to be the solid line. And the one that's on the left is going away from you. And this is D. And this is E. And this is F. All right, and then over here, same kind of thing. With our pink guys from here. Thing that's on the solid line is still on the solid line in the plane of the paper. The one that's on the left comes out towards you. The one that's on the right goes away from you. I think we're done. All right, so that is the basic story on the conformations of butane and other similar acyclic compounds. If you have any questions, please send them to me.